Here are the answers for the Section 8-1 homework assignment. On page 301, written, we're asked to do the midpoint and to find the length of a segment connecting these two ordered pairs. So let's do question A first. We want to find the ordered pair that's exactly in the middle between these ordered pairs. That would be the average of those numbers. So you might be able to average them mentally. The average of a -5 and a -5 is -5. And the average of 3 and -2 is the number that's halfway between 3 and -2. That number is 1/2. Well, what if you're not able to do that mentally? Then you're going to want to use the midpoint formula. To find the midpoint, let's call it M. You would average the x-coordinates, add them together, and divide by 2. And you would average the y-coordinates, add them together, and divide by 2. In our problem, x1 is the -5. x2 is the -5. The 3 is y1, and the -2 is y2. So make those substitutions. -5 plus -5 divided by 2, comma. And now for the y values, we have 3 plus -2 divided by 2. When you figure this out, -5 plus -5 is -10, and -10 divided by 2 is -5. For your y-coordinates, 3 plus -2 makes 1, and 1 divided by 2 makes 1/2. Notice this is the same answer that I got earlier. It's just that I had done that averaging in my head, and I encourage you to do that if you're able to. Now for part B, we're asked to find the length between this dot and this dot if you graphed it on a grid. To do this, we're going to use the distance formula. The distance equals, let's use the letter D to represent distance for now, the square root of x2 minus x1 squared plus y2 minus y1 squared. This is called the distance formula, and we created this in our lesson. Let's make substitutions. x2 is -5 minus x1 is -5. Now let's subtract our y values. y2 is -2 minus y1 is a 3. Now let's work to simplify. -5 subtract -5 makes 0. -2 subtract -3 is -5. Next step. 0 squared is 0. -5 squared is 25. So 0 plus 25 makes a 25 in the radical. Final step, the square root of 25 is 5. So if we were to graph these two dots, they would be 5 units apart on the grid. Number 3, same directions. In part A, we're going to get the midpoint dot, and in part B, we're going to get the distance, or the length between the dots. To find the midpoint, you average the x and y coordinates because you want to find the x coordinate that's exactly halfway between this x coordinate and this x coordinate. So maybe you can do it in your head. 3 plus 12 makes 15, and 15 divided by 2 is 15/2. Now let's average our y coordinates. The average of 2/3 and 2/3 is 2/3. If two numbers are the same and you want to average them, you just get that same number. If you're not able to do this in your head, then you have to take the time to show out the midpoint formula. The formula is written back here in question number 1, but what you do is you make substitutions. This is x1, this is y1, this number is x2, this number is y2. Add the x's together, so 3 plus 12, and then divide by 2. Add the y's together, 2/3 plus 2/3, and then divide by 2. This is why this first part turns out to be 15/2. And right here, this turns out to be 2/3, because 2/3 plus 2/3 is 4/3, but 4/3 divided by 2 is just back to 2/3. Now part B, we want to get the distance from this dot to this dot. We use the distance formula. I've written that formula in the previous question. We need to make our substitutions. So first you take the x2 and subtract the x1. Then you take the y2 and subtract the y1. Now let's figure out what's in the radical. 12 minus 3 makes 9. 9 squared makes 81. 2/3 minus 2/3 makes 0, and 0 squared is 0. So this is the square root of 81, which is equal to 9 units. Number 5, part A, we want to get our midpoint. So we want to average the x and y coordinates. What number is halfway between 3 and 4? It's 3.5. What number is halfway between -2 and -1? It's -1.5. Certainly you could do fractions or decimals here, and that would be the same. Now for question B, we want to get the distance between them. So we use the distance formula. One set of parentheses squared plus another set of parentheses squared. Now what goes in here? What are you doing in these parentheses? You're subtracting the x coordinates. You're finding the difference between them. This x coordinate is 3, and this one's 4. So what's the difference between 3 and 4? Well, 4 minus 3 would make 1 unit. Now in these parentheses, you're finding the difference of the y coordinates. This y coordinate is -2. This y coordinate is -1. What's the difference between them? How far apart are a -2 and a -1? -1 subtract -2 makes 1 unit apart. So let's do some work inside the radical. 4 minus 3 makes 1, and 1 squared makes 1. Over here, when you subtract, you get 1, and 1 squared makes 1. So our final result is the square root of 2. Number 7, let's first get the midpoint and then get the distance. Let's call the midpoint M. The midpoint will be an ordered pair. It will have an x coordinate and a y coordinate. Average the x and y coordinates from up above. So what's halfway between 1 square root of 2 and 2 square root of 2? That would be 3/2 square root of 2. What number is halfway between a -1 and a +3? That would be a 2. If you're not able to do this in your head, then use the formula. Actually show how you're adding together the x values and then dividing by 2, and show how you're adding together the y values and dividing by 2. When you work this out, you will get this same answer that I have here. Now question B, what's the distance between these two dots? So distance equals square root. In the square root, we're going to subtract our x's and square it, and then we're going to subtract our y values and square it. So let's subtract our x's. 2 square root of 2 take away 1 square root of 2 makes square root of 2. Now let's work with the y coordinates. A 3 take away a -1 makes 4. Next up, let's work in the radical. The square root of 2 squared makes 2, and 4 squared makes 16. So this is the square root of 18. We know from our sections about simplifying radicals that we can't leave it like this if it's possible to factor the 18. Well, 18 is the same as 9 times 2, right? So the square root of 9 is 3, and then leave the 2 in a radical. Number 9, first let's get the midpoint. So we want to average our x coordinates and our y coordinates. So what's halfway between 1 square root of 5 and 3 square root of 5? That would be 2 square root of 5. What's halfway between 4 square root of 7 and 3 square root of 7? That would be 3.5 square root of 7. You could certainly write this as 7 over 2 square root of 7 if you like. Now let's get our distance. The formula involves a square root. The formula involves working with the x coordinates and squaring it, and working with the y coordinates and squaring it. Now what do you do with the two x coordinates in the formula? You remember how it says x2 minus x1? Well, here's our x2. Here's our x1. Let's try to subtract them mentally. 3 square root of 5 minus 1 square root of 5 makes 2 square root of 5. Remember how over here in the formula it goes y2 minus y1? Well, here's the y2 and here's the y1. Let's try to subtract them mentally. 3 square root of 7 minus 4 square root of 7 is negative square root of 7. Next step. In the radical, let's do the squaring. So 2 square root of 5 squared makes 4 times 5. Or certainly you could save a whole step of work if you just wrote 20 right there. Now over on this side, negative square root of 7 squared makes positive 7, because a negative squared is positive and square root of 7 squared is 7. So next step, we get the square root of 27. Now we're not done, because 27 can factor as a 9 times a 3. And the square root of 9 is 3, and then this 3 right here will stay in a radical. Number 11, the same thing. Just because there's letters in there, don't let that stop you from finding the midpoint by averaging things. What's exactly halfway between an A and a 3A? That would be 2A. What's halfway between positive B and negative B? That's a 0. If you need to show the work, that's okay. You would add your x coordinates together and divide by 2, and you would add your y coordinates together and divide by 2. A plus 3a is 4a, and 4a divided by 2 is 2a. B plus negative b is 0, and 0 divided by 2 is 0. Now for question B, we want to get the distance between these numbers. So distance equals square root x2 minus x1 squared plus y2 minus y1 squared. Let's make our substitutions. The second x-coordinate is 3a. The first x-coordinate is a. The second y-coordinate is negative b. The first y-coordinate is b. Let's work inside the radical. 3a minus a makes 2a. And over here, negative b minus b makes negative 2b. Next step. 2a squared makes 4a squared. Negative 2b squared makes 4b squared. And here's one way to show the answer. It is possible to use some factoring and to factor out the 4 away from the a squared plus b squared, and then you could take the square root of the 4. So another possible answer is 2 square root of a squared plus b squared. Either of them is fine. Number 13. This time we're not asked to find the midpoint between these two dots, but we're told that this one is the midpoint between A and B. So what we need to find out is, what were the coordinates of the A so that point M ends up in the middle? Well, if the 7 has to be in the middle between 5 and something, then what is that missing x-coordinate? It would be a 9, because the midpoint value 7 is the average of 9 and 5. Now let's figure out this missing y-coordinate. Negative 3 is in the middle between 4 and what unknown number? It would be negative 10. Well, what if you're not able to do that mentally? Then you can use the formula. Remember, our formula is that the midpoint is equal to the average of your x values and the average of your y values. Well, our midpoint is 7, negative 3. And for our x values, we didn't know our first x value for point A, but we did know our second x value was 5. For our y values, we did not know the first y value for point A, but we did know that the second y value was a 4. Let's take this equation set up and separately work with the x coordinates and the y coordinates. x1 plus 5 all divided by 2 is equal to a 7. So what is the answer for x1? You would first multiply both sides by 2, getting that, and then you would subtract 5, getting 9. Now let's create an equation involving the y values. So y1 plus 4 divided by 2 is equal to negative 3. To solve this, you would first multiply by 2. So now you have negative 6 over there, and then you would subtract 4 from both sides, getting negative 10. So I have the same answers that I figured out in my head. Number 15 has 4 parts to the question. The first thing we're supposed to do is take the ordered pairs that the book gives us and graph them, and then draw lines to create a triangle. So let's make a grid and do that. When I look at number 15, I notice that none of the numbers given to me are negative numbers. So I'm only going to draw quadrant 1 to save time. The other thing I notice is that the highest number in any of the ordered pairs is the number 5. So I'm only going to take the time to make 5 marks. Any more than that is unnecessary. In number 15, we're given 1, 4. That's located right there. And we're given 5, 1. That's located right there. And we're given 5, 4. Located right there. We're told to draw segments connecting them to create a geometric figure. What angle is it right in that corner? That's a 90-degree angle. It's common to put a little square box in there. You'll learn that in geometry class if you haven't had geometry yet. We're asked for the perimeter of the triangle, the distance around the outside. So we first need to find the lengths of all the sides. The one that is horizontal is easy to find. It stretches from a 1 on the x-axis across to a 5. So how many units is it from 1 to 5? That's 4 units long. The vertical side is also easy to find. It stretches from 1 up to 4. So how far is it from 1 up to 4? That's 3 units. The diagonal one, though, requires the distance formula to solve for. So let's do that in this space down here. Distance equals the square root. We're going to subtract some x values and subtract some y values. Remember that this dot right here was at 1, 4, and that this dot here was at 5, 1. So let's subtract the x values. Let's subtract the 1 and the 5. 5 take away 1 is 4 units. Now in this set of parentheses here, let's subtract the y coordinates. We have a 4 and we have a 1. That's 3 units apart. Now let's work in the radical. This is 16 plus 9, which makes the square root of 25, which is equal to 5. This diagonal side of the triangle is 5 units long. Once we've labeled the lengths of all the sides, we can get the perimeter. 3 plus 4 plus 5 is 12 units. We're asked if this is an isosceles triangle. An isosceles triangle is a term from geometry class. It refers to a triangle that has two equal sides. Well, then the answer is no, because it doesn't have two equal sides. They are all different lengths. Is it a right triangle? This is also a term from geometry class referring to the angles. Does it have a 90-degree angle? Well, sure it does, right there. So the answer is yes. Then question D, if it is a right triangle, we have to get the area. So the formula for area is 1/2 times the base times the height. Let's make some substitutions. If we consider this side to be the base of the triangle, we could fill that in for base. And then let's consider that side to be the height of the triangle. Fill that in for height. So 1/2 times 3 times 4 is 6 square units. It might not be immediately obvious when you look at the triangle that that side's the base and that side's the height, but you imagine rotating the triangle a little bit, kind of flipping it on end. Then imagine it's sitting on the side that's 3 units, and the side that's 4 units would be the one going upwards in the air, which would be the height. Number 21. We are given ordered pairs in the book, and we're asked to show that they line up on a straight line, which is what collinear means. But we're asked to show this twice, one time using slope and one time using distances. So first of all, what are the ordered pairs for 21? We have point R at 7, -1. We have point S at 9, 4. And we have point T at 13, 14. If we were to graph them, apparently they do line up in a straight line. But let's prove that they do by using slopes. For dots to exist on the same diagonal line, the slope between any two of the dots will be constant. So let's first find the slope of RS by using the slope formula. Recall the slope formula is y2 minus y1 divided by x2 minus x1. So we're comparing R and S. So 4 minus -1 makes 5. And now your x values. 9 minus 7 makes 2. That slope is 5/2. Now let's find the slope of ST to see if it's also 5/2. So we're comparing S to T using the same formula. So 14 minus 4 makes 10. And now your x's. 13 minus 9 makes 4. This reduces to 5/2. Notice it's the same slope so far. Finally, let's find the slope of RT. 14 minus -1 makes 15. And 13 minus 7 makes 6. This reduces to 5/2. We got the same slope every time, so that means there's a consistent pattern between the dots. They do line up with each other in a straight diagonal line. Now question B, we're asked to do the problem again, but using distances. The idea behind this is, if you were to find the distance from one dot to another, let's just make believe it's 2 units. And you were to find the distance from this dot to another dot, let's just make believe for now it's 5 units. If those added up to the distance from the first dot all the way to the third dot, then they must lie in a straight line. So let's find the distance from R to S. Remember that in the distance formula, you're subtracting x values and subtracting y values. When we subtracted x values before, we got 2. When we subtracted y values, we got 5. This makes the square root of 29. Let's now find the distance from S to T. When we were doing our slope and we subtracted x values, we got 4. And when we were doing slope and we subtracted our y values, we got 10. This makes the square root of 116. Now let's get the distance from R to T. When we subtracted our x values earlier, we got 6. And when we subtracted our y values earlier, we had figured out it was 15. So this makes the square root of 36 plus 225, which is 261. Now, the point is that if you add together the two shorter distances, and that is equal to the longer distance, then that meant that the dots must have lined up in a straight line with each other. So what we need to know is the square root of 29 plus the square root of 116 equal to the square root of 261. Let's use a calculator to help us. The square root of 29 plus the square root of 116 is the decimal 16.15 with some more numbers. Now I'm going to type in the square root of 261. And, no surprise, it's 16.15. So we have shown that the three dots are collinear by using distances. Next, we're going to do 3 of the word problems. The first one says, find the length of the diagonal of a square. So I've drawn the square and drawn in the diagonal, and I'm calling it x for now, since I don't know how long it is. We're told the area was 40. So if the area is 40, then each side must have been the square root of 40. Because remember how the area of a square is length times width? So that number times that number would be 40. Let's use the Pythagorean theorem, which we discussed in the lesson because it's what led to our distance formula. In general, the Pythagorean theorem is c squared equals a squared plus b squared. But what the c and the a and the b are even representing are sides of a right triangle. The letter a is your altitude, your vertical side of a right triangle. The letter b is your base, the horizontal side of a right triangle. The letter c is the hypotenuse, the diagonal side of a right triangle. Let's make substitutions. X squared equals the square root of 40 squared plus the square root of 40 squared. This makes x squared equals 40 plus 40, which is 80. Now let's solve for x by doing a square root. Remember in an earlier lesson, we said that when you do a square root, you get 2 answers, plus and minus. But we have a real-life problem this time. Can the length within a square be a negative number? Does that make any sense? Well, no, it doesn't. So I'm not going to put plus minus. I only want the positive answer. So we could leave our answer as the square root of 80, or we could get a decimal for that on the calculator. This rounds off to 8.9 units. Number 3, we're told that there is a vertical pole 24 feet tall coming out of the ground. From the top of the pole coming at an angle down to the ground is a support wire. And that wire is touching the ground at a point that is 7 feet from the bottom of the pole. When I draw this, I see a right triangle. So again, it's the Pythagorean theorem that applies. The letter C is the hypotenuse. It's the diagonal side of the triangle. The letter A is the altitude. The letter B is the base. So for C, I'm going to fill in X. For A, fill in 24. For B, fill in 7. So this is x squared equals 625. To solve for x, we use square root. Like last time, I'm not going to say plus or minus. Because this is a real-life problem, I'm trying to find how long a wire is. A wire can't be a negative distance long. The square root of 625 is 25. Finally, number 5. There's a drawing of a circle. Inside the circle, there's a square. There's a little segment drawn in the book with the letter D on it. And on the screen, I've drawn that in green ink and written the letter D on it. We're told that the distance all the way across the circle is 4. That means that the distance from the center out to the edge of the circle would be 2, and I've labeled that in red. I want you to notice as well from the center just going straight across out to the edge would also be 2. Do you see a right triangle where the diagonal side is 2, this side is labeled x, and this side is labeled x? Let's figure out what x is using the Pythagorean theorem. So c squared equals a squared plus b squared. For letter C, fill in 2. For letter A, fill in x. For letter B, fill in x. Now let's solve this equation. We have 4 equals 2x squared. Now divide both sides by 2, so we get 2 equals x squared. Now do the square root. Again, only doing a positive square root because it's a real-life problem and x is a distance. So we get x equals the square root of 2. I can go inside my drawing here and I can now label that distance from here across to here as the square root of 2. Well, do you remember how far it is from the center all the way out to the edge of the circle? It's a regular 2. Look at this drawing. From here to here is the square root of 2. This little piece is d. And all the way across is 2. The idea is I can add together these two pieces and I know the answer is 2. So the square root of 2 plus d is equal to 2. Subtract the square root of 2 from both sides to get the letter d alone. And here is our answer. Because this is a real-life problem, it might make sense to give a decimal for this. This is approximately 0.58, and I think that the numbers in the book were given in inches.